Okay, this is page 221. This is scenario 4 for chi-square goodness of fit. So a random sample of, and the number of televisions that American families have is distributed as following. 10% have no TVs, 16% have one, 55% have two, 11% have three, and 8% have four or more. A random sample of 600 families in the far western US resulted in the following. Now, this is all US. And by the way, that gets kind of confusing about this problem. This is all US, and this is just western US. So we have a random sample of 600 families resulted in the following data. Okay, we have 66 families that don't. We have 119 that have one, 340 have two, 60 have three, and 15 have four or more. At the 1% significance level, so at alpha equal 0.01, does it appear that the distribution, the number of TVs for far western US is different from that of the population as a whole? Well, first off, when I look at this, it's like, okay, we have multiple categories, all right? And because I have multiple categories, this is going to make it some sort of chi-squared. And I notice that I really only have one variable, so this makes it a chi-squared goodness of fit. So my null hypothesis in this case is HO, the distribution of TVs in the West is the same as the US. HA, the distribution of TVs in the West is not the same as the US, or is different than the US. I'm just going to use not the same. All right. So the distribution is the same or is not the same. So then we get to our conditions. And we have random sample. And they actually gave that to us. All right, so random sample is given. Number 2, expected values. Well, we got to go calculate those. And what we have here is when I'm looking up here and I go, well, we have percentages. Well, the first thing we should always do is we should total this. When we total this, I add all these up and I get 600. All right, so I get 600 here. And I have 10%. So expected value, remember, expected value is basically NP. So in this case, equals 600 times 0.1. So we would expect there to be 60. And then here, it's going to be 600 because our N is the same, but our percent is 0.16. So I expect there to be 96. Then 600 times 0.55. So that means I would expect there to be 330. 600 times 0.11. So I would expect there to be 66. And here's 600 times 0.08. And I would expect there to be 48. All right. And if I totaled all those values up and I did this correctly, it should add up to 600. But regardless, when I look at this, every single one of those values is greater than 5. So expected value is all greater than 5. C table. All right, the next thing, my observed. Well, when I look at my observed are all counted data. Observed values, all counted data / whole numbers. All right, all counted data / whole numbers. We've already said this is a chi-squared. So this is chi-squared equals observed minus expected squared over expected. And my degrees of freedom. Well, how many categories are there? Well, we have the category of people with 0 TVs, 1, 2, 3, 4, and 5. So categories are going to be, so our degrees of freedom is cat minus 1. So in this case, 1, 2, 3, 4, 5 minus 1. Degrees of freedom is 4. All right, so I need to input this data into my calculator, stat edit. And I end up 66, 119, 340, 60, and 15. That's what I observed happen, because this was my observed frequency. What I expect to happen is I expected to get 60, 96, 330, 66, and 48. And I can go ahead and start plugging into my formula. So my chi-squared equals 66, my observed, minus my expected, 60 squared over 60, plus plus 15 minus 48 squared over 48. And what does that give me? Well, I'm going to run my test. So second quit, stat, test, chi-squared goodness of fit. Degrees of freedom is 5 minus 1 or 4. And I end up getting a p-value somehow or another. I don't think, yeah, there we go. Chi-squared equals 29.646. That's a pretty large p-value. I mean, a pretty large chi-squared value. And my p-value, and remember, is really, if I have more than 4 zeros, it's approximately 0. So my p-value is approximately 0 at alpha equal 0.01. This is less than. So this is approximately 0. And I got that from that being to the -6 power. It's less than 0.01. So we reject the null. And we have a 0.6, a 5, a 0.3, a 0.54, and then we have a 22. So the 4 or more had the greatest contribution. This had the largest contribution. All right. So here's our conclusion. Our p-value is approximately 0. We reject the null. There is sufficient evidence at alpha equal 0.01 to suggest that TV ownership in the West is not the same as the US. All right. And our contributions were approximately 0.6, 1.352, 0.303, 0.545, and 22.688. This is for 0 TVs, 1 TV, 2 TVs, 3 TVs, and 4 TVs. All right, so this one had the largest contribution. All right, this was the largest contribution. And our observed was less than our expected, so it was our largest and it happened to be negative. All right, so it was largest and it happened to be negative because our observed was less than what we expected. O less than E equals a negative. And then when we get over here, we observed 119. This was greater, so our observed was greater than our expected, and that's a positive. And the 1 TV, that had my largest positive effect, okay? All right, so that concludes our notes on chi-square goodness of fit. Thank you.